All right. So, sorry guys, I'm not be able to upload the video earlier since here in our location, no, um, meron siyang power interruption. So, it's been around 24 hours. No? So, luckily na right now, we were able to find time to upload itong video. Okay? So, all right. Here's our topic for today. Right? So this is regarding with the storage management. And storage management refers to the process of managing data, storage equipment used to store user or computer-generated data. It involves optimizing the use of storage devices rather, and protecting the integrity of data across various media. Right? So ito daw yung ano no, yung data store or data storage equipment that we are using to store daw yung mga data natin or mga files natin. Alright? Na ginagamit using our computer or operating system. Okay? Alright. So anyone of you really familiar with the storage management or the storage. So somehow even our cell phone, we also have the storage. Diba, pag bumibili tayo ng iPhone, di ba? So ang tinatanong natin, ano bang storage niya? Is it um, 512, 256, 128, and or etc. Or 1 TB, di ba? So may mga ganong type of yun yung mga type of storage that we are using when we are buying a iPhone or Apple product, right? So our topics would be storage management, and under of it we have the secondary storage structure, and we will be discussing the storage mass storage overview of mass storage, IO systems, IO hardware, application IO interface. Okay, so for the storage management, we have the file system, implementing file system, secondary storage structure, IO and IO systems, right? So this structure describe our address as large one-dimensional arrays of logical blocks, where the logical block is the smallest unit of transfer. So um, this structure refers to the organization and layout of data on a physical disk. It involves several layers, no? Marami daw layers and component that work together to store and retrieve data efficiently, right? So the one-dimensional array of logical blocks is mapped onto sector of the disk sequentially. Meron daw siyang sequence. And we have the sector 1, the first sector of the first track on the outermost cylinder. And we also have the mapping proceeds in order through the track, then the rest of the tracks in that cylinder. Okay? So, ito yung itsura niya. No? So, kasi meron itong read and write heads. So, ito yung nagmababasa daw uh, ng disk. Right? And then, these are the tracks or the track. And then the cylinder, no, meron pang another parang somehow disk. And then this is the surface, and this as the outer will be the platter. Right? So ito yung marinig nyo dun sa, meron tayong hard drive, external hard drive. Kung papakinggan natin yung tunog ng hard drive, ilalapit natin sa tenga natin, is that meron tayong narinig na umiikot. Lalo na kung hard disk drive siya o yung HDD na tinatawag natin. Umiikot siya kung papakinggan natin. Kaya minsan, kapag nagkakaroon siya ng problem, yung hard drive natin, parang marinig nyo parang pumipitik, lalo na kapag nalaglag yung hard drive natin. Diba? Marinig natin na parang bumibitik siya. So, yun yung one of the uh, one of the sign na mayroong problema yung hard drive natin. Okay? So, this access time, no? Seek time. Time to position heads on cylinder. A fixed head, this does not require seek time, but it's more expensive than a moving disk. So one of the major reasons for slow access to files in the hard drive or hard disk, it is time it takes to move the read-write head from its structure track position to desired track position. So meron daw tayong latency, no? Latency, a time din na between the stimulation or simulation and response. Okay? And rotational latency delays in accessing material. Once it accomplished, time required to wait for data to rotate around underhead. No? So meron daw may mga konting rotational rotate or latency. Okay? And then next is transmission time, time to transfer information once it is under the head, no? Under nasa ilalim daw siya ng head. Okay? And access time, seek time plus rotational latency plus read-write transmission time. Okay? So this is scheduling. This is the technique that OS uses to manage the I/O. I/O request. So hindi siya yung sabay-sabay. Tulad ng pagka nagka-transfer tayo ng files, di ba? Diba, pagka copy natin ng isang folder to another folder. And then sabay ginawa natin, alam mo, multiple files yung na-transfer natin. Sorry. Hindi naman siya automatically na pagka gusto natin, copy file 1, copy natin sa kabilang folder, pagsasabayin natin siya, folder 1 and folder 2, pagsasabayin natin, i-copy to different folder. Lalo na mabigat siya. Hindi naman siya sabay na pinatransfer eh. So, inuuna muna natin yung first come, first serve. Sino ba yung unang transfer natin? Is it the folder 1 or the folder 2? And then, ipa-priority niya yung folder 1. And then, once natapos na si folder 1, kung una si folder 1 once tapos na siya, saka that's the time na si folder 2 will be transferred to different folder. So, yan yung first come, first serve na tawag natin. Okay, and then the operating system is responsible for using hardware efficiently. For the disk drive, it means having a fast access time and disk bandwidth. And the disk bandwidth is the total number of bytes transferred divided by the total time between the first request for service and the completion for the last transfer. And accomplished by minimizing the seek time. Okay, and seek time approximate seek distance. Okay, so this I/O request specifies whether the operation is input-output. No, if we're using the mouse or keyboard or other I/O request. This address block number, which is translated into drive, cylinder, surface, and sector coordinates. And we also have the memory address to copy from or copy to or from. Okay, bytes count giving the amount of information to be transferred. Okay, so this is scheduling. Many requests may be pending at once. We should be handled first. So meron tayong mga tinatawag na first come, first serve. And moving strategy develop, attempting to manage the overall disk seek time latency is not controllable. And transfer time depends on the size of the transfer request. Okay? Magkakaiba daw siya ng transfer. So meron tayong different strategies. No? We have the first come, first serve, like what I mentioned earlier. And the SSTF, or the shortest seek time first scan. Under scan, meron tayong C-scan, and meron tayong loop, NC loop. Right? So I think we will be discussing until C-scan. So for the first scheduling, which is the simple or the simplest form, first come first serve scheduling basis, or first come first serve scheduling. And request serve in order of arrival. Kung sino daw yung unang dumating. Advantage, this is the simple queuing. And disadvantage, does not provide the best seek time. Hindi daw siya yung pinakamabilis na or pinakamagandang seek time. Okay? So for example, no, assume that the stream of the track access request. So meron tayo, ito yung mga access request natin. 118, 59, 110, 25, 105, 63, 128, and 80. So basic assumptions are there are total of 200 tracks, no? And then number natin from 0 to 99. Outermost si 0, outermost track, and then si 99 is the innermost track. The read-write head is currently servicing a request for track 70, and all the requests given above have arrived prior to its completion. Okay? No other request will arrive. Okay? So ito daw yung sample niya. So from 70, sabi natin dito, no? The read-write head is currently servicing a request for track 70. No? Nandito siya. Ang unang sineservice niya, or currently sineservice niya, is the track 70. Okay, kaya nagkaroon tayo ng anong tawag dito? Parang axis no? X and Y siya. Graph, no? So, ito si 70. And then, ano ba yung next natin? 118. Yes. So, ano daw siya? First come, first serve, no? Until from 118, 59, 110, 25, and so on. Okay? Until ma-reach natin yung 80. Right? And then, assumption, the stream, assume the stream of track access request, ito, no? Until ma-reach natin yung 80. So, the total number of tracks transverse will determine the performance of an algorithm. So, sabi niya, no, from track 70, mula sa track 70 to track 18, minus natin yung 118 minus 70 equals to 48 tracks. Okay? And then, ganun din kay yung pupuntahan naman niya, no, 118 to 59, 118 minus 59 is equal to 59 tracks. So, from 59 to 110, and then 110 to 125. So you can see 110 minus 59. So, and then 110 minus 25. Diba? And then, ito yung equal niya, nasa gilid, no, 50. For the 110 minus 59 is equal to 51, while 110 minus 25 is 55. So, yun niya, nandito na tayo. Dito na tayo. 25 to 105, no? As you can see, ito, 105 minus 25 is equal to 80. And then, meron din tayo dito na 105 to 63. No? So, ang 105 minus 63 is equal to 42. Okay? And then, dito na tayo, 63 to 100, no? 100 minus 63, 37, and 100 minus 28, is equal to 72. And then 28 minus 80. 28 to track 80. So 80 minus 28 is equal to 52. So total natin pagka pinag-add natin yan lahat, ha? So lahat nung sagot na answer natin, pag-add din natin, and the total of 526 rockets. Okay? Yeah. Next natin. The shortest seek time first, or SSTF. So in this algorithm, the request which is closest to the current head position will be service next. Pinakamaano doon, no? Pinakamalapit do sa current head. Okay, compared to FCFS algorithm, it has better performance in terms of minimizing the head movement. Ano ba yung disadvantage nito? No? Starvation, because it prioritizes requests that are close to the head's current position. There will be instances that request for trucks that are far from the head's currently position may wait indefinitely. Okay? So ito yung sample niya. No? So, same ulit, no? Yung assume natin the stream of the truck's access request. Now, since truck 63 is the nearest truck to the nearest truck is 70 eh. I mean, the truck is under the 70 yung pinakauna eh. Ito yung sinaservice niya na una. Now, ang next daw will be, it will be service next. No? 63 yung pinakamalapit eh. Bakit natin nasabing pinakamalapit yan? Kasi from 70 to 63, ilan ba yan? 7. No? Pagka yung pinakamalapit na makapunta ka, yun yung sinasabi nga na seek time first. Okay? Then followed by 59. So in next na pinakamalapit na 63 is 59. Kaya next is 59. Which is the nearest to the 63. Okay, so apat lang eh. Pag compare mo siya dito sa mga numbers na to, wala na eh. Wala nang pinakamalapit kay 63 kundi si 59. Okay? And then next naman, sino ba yung pinakamalapit kay 59? Si 28 ba or si 25? Si 80. No? Kasi pagka minus mo, 59 minus 28 is around 31. Huh? Yeah, around 31 siya, no? Natin. 59 minus 20. Yeah, 31. Tapos, kay 59 minus 25, o 34 naman. So, si 80 naman, 80 minus 59, o 21. Kaya after ni 59, si 21, after ni 59, si 80 yung pupunta. So, ganun lang siya. Ganun lang yung seek time. Kung sino yung pinakamalapit. Okay? Alright. So, ito yung magiging graph niya. Huh? So, since until such time na ma-reach niya yung lahat, no? Mapuntahan niya yung lahat, no? Which is yung pinakamalayo, which is 25. Kaya siya yung pinakadulo. Yeah, ito yung pinakamalayo yung 25. Okay, so we're going to do the math, no? From 70 minus 63, 7, 63 to 59, 4, 80 minus 59, 21, 100 minus 80, 20, 105 minus 100, 5 trucks, no? And 110 minus 105 is 5 trucks, 118 minus 100, 110 is 8 trucks, and then 180 minus 28 is 90 flats. And then 28 minus 25 is 3 flats. So, ganun din siya. No? Katulad nung kanina, sa first come, first serve, ima-minus natin siya from 70 to 63. Ito siya. Tapos 63 minus 59. Kaya meron tayong 4. Until ma-reach natin yung pinakadulo. Okay? So, ang total natin yan ng read-write head movement would be 163 watts. Okay? That's for the shortest seek time first. Madali lang naman siya. No? Next natin would be scan scheduling. Also called as the elevator algorithm. No? Continue in the direction of first movement until reach and then reverse and head in the other direction. So moves completely to the ends of the disc. Okay? So need to know direction of movement, of head movement. Goes from one direction to another. No starvation problem. Waiting time is its variance are position independent. Okay? So the string of tracks access request is ito naman daw, no? 199, 118, 59, 110, 25, 105, 63, 100, 28, and also 80. Okay? Assume that the head is moving towards the innermost request when it serves the request for tracks 70. Okay? And then it proceeds towards track 199, no? Ito daw yung pinaka mataas or yung toward track 99 or the innermost track. Servicing 80, 110, 100, 105, 110, 118 along the way. Okay? Upon reaching the track 199, it goes back and moves towards the outermost track. It then proceeds towards track 0, outermost track, servicing tracks 63, 59, 28, and 25 along the way. Okay, so let's see in the graph. Now, ito is from 70, ito daw si current servicing daw is 70. And then it then proceeds towards track 199. Papunta daw dun sa si 70 papuntang track 99. Okay? And then servicing daw si 80, 100, 105, 110, and 118 papuntang 199. Okay? And then upon reaching 199 down, it goes back and moves towards the outermost. Outermost is as a 0. Okay? And then servicing daw niya servicing daw niya si 63, 59, 28, 25 towards Totus outermost yan. No? That is the scan schedule. Okay? Next. Okay? So total daw nito, no? Ito, ganun din, katulad ng ginawa natin kay SSTFs and then kay FC first come first serve or FCFS, no? Nagsimula tayo ay 70, minus natin si 80. Until such time na makarating tayo dun sa 25. Ganun din ang ginawa natin dun sa and then, and if you're going to to get yung difference, no? Yung mga pinagma-minus natin, sinubtract natin, ang pinag-add natin yan, no? Yung difference, in-add natin lahat ng difference yan. And then, ang total is 303 laps. So, this is the answer. Okay? So, next, we have the C-scan scheduling. It is a modified version daw siya ng scan scheduling algorithm. Circular scan scheduling. No? The read-write heads or head moves from the outermost track to the innermost track and services any disk access request encountered. When the outermost track is reached, no? When the innermost track is reached, yung pinakamataas, no? It goes back to the outermost track without servicing any request. Okay? Upon reaching the outermost track, the process is repeated. It goes back to the innermost track again and services this request along the way. It is the track in a circular fashion. Pag sinabi natin circular, circle lang. And then, in this algorithm, the waiting time is no more than 1. Okay? Ito yung sample niya. No? Ganun ulit, no? Ito pa rin yung access request natin, no? 199, 118, 59, 50, 110, 25, 105, 683, 100, 28, and also 80. Okay? Treat this as if it were circular with the last track adjacent to the first one. Okay? It reaches the disk, the end of the disk restarts again on the other side. Then the smooth head all the way to the end of the disk. Always goes in one direction. No starvation problem, uniform average waiting time. Okay, ito yung example. Ito na yung track niya. So, nagsimula tayo kay currently servicing, which is 70. Towards to 100, to innermost, which is the 199. Sinervice daw niya yung 70, katulad kay C-scan, no? Kay scan pala, sorry. Kay scan na service niya is 80, 100, 105, 110, and 118. And then, papunta naman siya kay, no? Papunta naman siya dito kay 0 or kay outermost. May nag-restart siya ulit. No? Sinervice naman niya yung remaining, which is 25, 28, 59, 63. So, hindi katulad ni scan, dinaanan na niya agad sinervice na niya agad yung remaining. Ito, from innermost, pumunta muna siya kay outermost bago niya sinervice yung remaining. Okay? So, you're going to get yung tracks niya, no, yung computation ng tracks natin, or yung differences, no, from 70 to 80 and so on. Pag sinam natin yung differences nila, ang total natin is 391 tracks. Unlike kay scan yung kay scan. 303. Kay C-scan naman is 391. Okay? So, what is the comparison or difference? No? Again, yung like I mentioned, from current servicing track, which is the 70, pareho silang dinaanan nila yung sinervice nila yung 80, 100, 105, 110, 180, going to the innermost track, which is 199. And then, Si scan dito, ito yung pinagkaiba, no? Si scan, bumaba na siya towards dun sa outermost, which is the zero. Um, sinervice na rin niya while papunta siya doon kay outermost. Pero hindi niya na-reach si outermost. Okay? So dito naman, no, kay C-scan, ganun ulit, from current service niya is yung servicing niya is 70, dinaanan niya rin si 80, 100, 105, 110, 118, going to 199, which is the innermost. Right? And then, pinuntahan niya muna si outermost bago niya sinervice ulit. So, nag-restart siya. No? Sinervice niya ulit si 25, 28, 59, 63. So, totally magkaiba. Okay? So, ulitin ko, dinaanan niya muna yung dinaanan niya muna yung outermost bago niya dinaanan yung rim. Okay, pero nagsimula siya nag-restart siya from 0, papuntang 25, 28, 59, 60. Okay? Alright. So, this is for this video muna, no? And later on, I will be creating the video for the loop scheduling. Right? I will be stopping for now and will upload it again. Okay? Thank you, guys.